Okay, 5.4 talks about multiple angle identities. And so we have 4 more categories of identities. And so notice the first group here is our double angle identities. Double angle, remember if something's doubled, it's being multiplied by 2. Alright, so we can see that we have sine of 2u is equal to 2 times sine of u times cosine of u. Tangent of 2u is equal to 2 times tangent of u, all divided by 1 minus tangent squared of u. But now look at this other side over here, the cosine of 2u. You have 3 options for cosine, okay? Cosine of 2u is equal to cosine squared of u minus sine squared of u. Cosine of 2u is also equal to 2 cosine squared of u minus 1. And cosine of 2u is also equal to 1 minus 2 sine squared of u. Alright, so which one do you use? It's up to you. What do you need when you're trying to prove an identity? What have you been given when you're trying to solve an equation? Okay, so you could use any of these 3 for cosine of 2u. Alright, so let's keep looking at them. So then we have our half angle identities. Notice in all of these, it's sine of u over 2 is equal to plus or minus the square root of 1 minus cosine of u over 2. The plus or minus, guys, depends on what quadrant is that u over 2 going to be in. Alright, same thing with cosine of u over 2. It's equal to either plus or minus the square root of 1 plus cosine of u all over 2. Again, depends on where that angle that u over 2 is at, what quadrant it is, on whether that cosine is positive or negative there. And then the same thing with the tangent of u over 2. It's equal to plus or minus the square root of 1 minus cosine of u over 1 plus cosine of u, or it's equal to 1 minus cosine of u over sine of u, or it's equal to sine of u over 1 plus cosine of u. Again, which one do you use? What do you need? Okay? Alright, and then the power reducing formulas. If you have a power that you need to be reduced down to the first power, okay? So we got sine squared of u for the first one is equal to 1 minus cosine of 2u over 2. Cosine squared of u is 1 plus cosine of 2u all over 2. And then tangent squared of u is equal to 1 minus cosine of 2u over 1 plus cosine of 2u. Alright, so now that I've given you some more identities, we can prove them using other identities. So example 1 here says, let's prove that sine of 2u is equal to 2 sine of u cosine of u. We know that's true because that's the first identity that they gave us above. But we've got to prove it. So I'm going to work on that left side. Alright? And so the left side here, how do we get 2u? Well, we know that's 2 times u, but that also means it's u plus u. So we can say the sine of 2u is the same as sine of u plus u. And then we can use our sum of sines formula from 5.3, where the first u is our alpha and the second u is our beta. So this is equal to sine of u, cosine of u, plus cosine of u, sine of u. Now remember, the order doesn't matter, okay, when you're multiplying. So let's see, my answer has sine of u and then cosine of u, so I'm going to make sure they're both in the same order. So I've got sine of u, cosine of u, plus, and then these two, it doesn't matter what order we put it in, so I'm going to just move the sine of u in front, so sine of u times cosine of u. Now I have 1 sine of u, cosine of u, plus 1 more. So how many do we have total? We have 2 of them. So we have 2 sine of u, cosine of u, which is what we were trying to prove that it was equal to. Alright, so we proved this identity here. Alright, so I'm going to go on and do an example 2 in this video as well. So in example 2, now we're going to prove that cosine to the 4th of theta minus sine to the 4th of theta is equal to cosine of 2 theta. Well, cosine to the 4th of theta minus sine to the 4th of theta, I see a difference of squares there because 4, the exponents of 4, we can take the square root of them. I guess I should say really the cosine to the 4th and the sine to the 4th we can take the square root of. Remember, to take a root of an exponent, you just divide it by that root. And it's a minus in between, so this is a difference of squares. And so I'm going to factor out this left side. So this is cosine squared of theta plus sine of squared of theta times cosine squared of theta minus sine squared of theta. Now remember, I got that because this is the same thing if I had x squared minus 4, okay? We'd have said square root of x squared is x, square root of 4 was 2, so we'd have done x plus 2x minus 2, okay? So I did the same thing. This is not related to this problem except for the formula being the same way, okay? So I took the square root of cosine to the 4th, which is cosine squared. I took the square root of sine to the 4th, which is sine squared, and I put them in parentheses. One parenthesis got a plus, the other one's got a minus. Now, we know that cosine squared plus sine squared is a Pythagorean identity, and so that's equal to 1. So I got 1 times cosine squared of theta minus sine squared of theta. And from above, we can see on our double angle identities, in the right-hand column up above there, the very first one says cosine of 2u is equal to cosine squared of u minus sine squared of u. So when I multiply these, I just get cosine squared of theta minus sine squared of theta, which according to the identity I just read to you, that is equal to cosine of 2 theta, which is what we were trying to prove. Oops. So we know that these were true.